This one's good. All right. Can everybody hear me okay? We got on room sound? Nice, okay. We'll give it a couple of minutes or a couple of seconds just to make sure that everybody is here that wants to be here. Um, so I hope you're all having a good conference so far, enjoying the talks. Today is a little bit different in terms of the track, so obviously things are a little bit more technical. You had the guys from EPFL in Boston this morning, or in East West Falls Church. And then today over here, we've got some introductory talks to SRS to give you a little bit of a better idea about what we do as a company, what srsRAN is, and what OCUDU will be. We have a talk from Niels, our DevOps engineer, later in the day. Or after this, he'll be discussing split 7.2 deployments with ORUs and srsRAN. Then we'll have Tracy Van Brakel from Rutgers talking about Next.G open source tools for learning, innovating, and commercializing. And then we'll have a talk from Ish, who will be replacing Dinesh, about building Edric with srsRAN and Project Janus. And then we'll have Pedro Alvarez from SRS discussing debugging TCP streams with srsRAN. And then finally in the afternoon, we'll have Asan from Asan Labs discussing a BOMA, which is their demo outside. So if you want to get a preview of that, you can check that out in the demo area during the lunch break. Okay, so that's the formalities for the room. So we'll get going. So my name is Brendan McAuliffe. I am the Technical Communications Manager at SRS. And I'll be giving kind of a brief higher level intro to srsRAN, into OCUDU, trying to summarize some of the discussions from yesterday, and also giving you a better idea of kind of who we are as a company and what we're doing at SRS. So a little bit about me first. So I have a master's in computer and electronic engineering from Trinity College in Dublin. I've been with SRS since May of 2020. I started out as a user success associate and then transitioned to application support engineer, and now as technical communications manager. So I have a background in engineering, kind of a technical background, and I've transitioned more so into these roles here. So documentation, community management, organizing this event, project management, comms and marketing, and then everything else in between. So wearing a lot of hats, but doing a lot of cool stuff. I'm not actively developing, so I can't answer any of your dev questions, but I can do my best to answer more high-level questions. Okay, so why are we here? What are we going to be talking about? So these are a couple of questions that I'm hoping this presentation will answer for you. So who we are as a company, why are we here? Not in the philosophical sense, but why are we here today discussing these things? Why OCUDU? So why have we chosen to go down this path? What is OCUDU? What are the hopes and dreams and aims for the project? Why the foundations of srsRAN is the perfect base to build OCUDU? And then a little bit about the ecosystem, a little bit about getting started with the code, and then a discussion on what's next. Okay, so a little bit about SRS. So we are a privately held company founded in 2012. We're headquartered in Ireland with offices in Ireland and Spain. We have a global customer base, so we're serving people across Europe, Asia, and the US. We have 29 team members, all of which are full-time. We're 100% software radio, and we're 100% organically grown. So we don't have any funding, or what funding obviously we have, but we don't have any investors or any external say over the company. We have four main areas of expertise. So software radio, obviously, telecommunications, obviously, software engineering, and signal processing. So everything we do is kind of built from this engineering first approach, where we're actually looking at the problem as a technical problem as opposed to a sales problem or a commercial problem. What do we do? So you all know we develop srsRAN. So we started out with srsRAN, or SRS LTE, which some of you may remember, then transitioned to srsRAN 4G, and now srsRAN Project, and soon to be OCUDU. We engage in commercial and publicly funded projects. So this is an overview of our current publicly funded projects. So these are across European Horizon and SNSJU calls, PTE, which is a Spanish call to develop a NTN testbed through the srsRAN project. We also have a DTIF project called NIRA, which is focusing on energy efficiency. So this is an Irish government-funded project. And then also a UNICO project, which is funded by the Spanish government. So a lot of work, a lot of different projects. Typically every year we're involved in, kind of 10 to 15 project calls for these various funding calls. And we have a pretty good strike rate. So we get kind of 2 to 3 in each call, which is nice. So it keeps us in touch with the research community. And typically these focus on ORAN, NTN, AI-RAN, and 6G. We act as what we say is a platform provider. So this means we go in and we try to align our development with the standard. So we're not going too far into kind of complex research, but as the platform provider, we are supporting these research institutions in kind of furthering the development and going further beyond the spec. How do we manage open source versus commercial? So how does this work? This has been the approach we've been using for the last 10 years. Obviously, with OCUDU, this will change a little bit, but it won't be too unfamiliar to the system we currently use. So we have this kind of open core model is what we call it for srsRAN project and srsRAN enterprise, which means that the code at the core is the same. So the enterprise code is built on our open source code, and we have advanced enterprise plugins which go on top of that. So the open source code is licensed, as you may or may not know, under AGPL v3. And then for commercial licensing, this is done on a more kind of ad hoc basis for each user. This will move slightly or completely into a BSD3 license for OCUDU, which basically means that you no longer need us to gain a commercial license to do productization or commercial advancement. You can do this directly from the OCUDU repository. From a commercial standpoint, Paul and Ishmael touched on this yesterday during their talks. We will still be a commercial entity offering kind of consulting services on top of OCUDU. You can learn more about that in the Vienna room. We have a product called SRS Advantage, which is basically a support package for OCUDU. So why are we here? Again, not the philosophical question, but the technical question on why we're here and what we're doing. So today we're building the Linux of RAN, but why are we doing that? So ORAN has had a shift from experimental and experimental setups to a more widely deployed ecosystem, right? We're seeing more and more ORAN systems being deployed, especially across Europe. And the next step for this is to, I guess, have a reference implementation, right? Something that we can all develop against that is the kind of gold standard for things to do. This is, as we're calling it, OCUDU, right? The Linux of RAN. But you may have some questions, right? How did we get here? Why are we doing this now? What is OCUDU and why are we using srsRAN as the foundation? So before we go to this, we'll look back a little bit and look at the kind of core concepts behind 5G and ORAN and open source. So what is 5G? Again, preaching to the converted here. I think you all know what 5G is, right? But over the years, obviously the technology has advanced quite significantly from release 8 in 2008 with LTE to now release 18 since last year in 5G, right? And so there's been clear increases in speed and throughput and latency, more needs from users, both commercial and everyday users like us. So putting the network under a lot more strain and offering more and more services over these networks. So what is Open RAN? Again, I'm sure all of you know, but let's briefly go over it. So ORAN aims to define open interfaces and components for 5G radio access networks, so completely disaggregating the RAN, bringing in more commercial investment, more vendors, more providers. And the main aims are as follows, right? So we want to promote interoperability. We want to be able to plug and play various components from various vendors to avoid lock-in. We want to reduce the costs. If there are more competition for platforms, it means the prices go down, which is good. It increases flexibility, so you can choose what you need based on your use case. You're not over provisioning, you're getting exactly what you need for your price or your use case or whatever that might be. Enhanced security. So as we open the standards and we open the interfaces, they come under more scrutiny, which means the security has to be higher. So the ORAN architecture, again, I'm sure a lot of you know what this is, but here we are for reference. So it's more than just a redesign of the radio access network, right? It adds new blocks, it adds new elements, it adds new interfaces, and it enables AI-RAN. So this is one of the main promises of ORAN, beyond the disaggregation and the addition of new vendors and new providers, but to enable AI to be leveraged properly for future telecoms networks. So we know about 5G, we know about ORAN, but why is open source important in all of this? So open source is vital for new and emerging technologies. It enables people to have a lower barrier to entry to research, right? So if you can make it easier for people to research and for people to use the products, then you are going to get better and better products. So, like I said, open source is key to enabling innovation, interoperability, transparency, cost effectiveness, and flexibility, right? So if you have an open source solution like srsRAN or OCUDU, similar to how Open RAN works, it brings the product, the code under a lot more scrutiny. So you have enhanced security, enhanced interoperability, and enhanced transparency over the development and the longevity and the life cycle of the product. So who benefits from this? Obviously, as researchers, we benefit, but also operators from reduced costs, developers because they have easy access to the latest features, there's open collaboration, and we have a clear development process. As for vendors, similar to operators, there's more opportunities, there's reduced costs, and there's differentiation between open source solutions. And then for end users, obviously, if you're developing a commercial product on an open source foundation, you get higher security because it's under more scrutiny, and you get lower costs because open source is free. Okay, so why OCUDU? So the challenge and the opportunity of OCUDU is kind of one of the more important aspects of it. So currently, proprietary RAN systems limit innovation and interoperability. We've seen that with vendor lock-in across ORAN networks and legacy networks. Open RAN has defined the interfaces, but has not defined the software foundation. So we've seen attempts at this before with the ORAN SC and other foundations to kind of define a de facto standard by which we should develop ORAN components. That really wasn't a success, in my opinion. Not speaking for SRS, but from my own personal perspective. So OCUDU should and will deliver this foundation, a carrier-grade open source CUDU stack under the Linux Foundation governance. So we aim to answer all of the challenges and all of the questions of these failed attempts with OCUDU. So building the Linux of RAN. Why now and what is it? So like we said, proprietary systems limit innovation and interoperability. Operators and researchers need something that's more flexible. They need something that can run on commodity hardware and not on, high cost, super specific platforms. OCUDU brings this open source carrier grade CUDU to the Linux Foundation, so under neutral governance with a higher reach, opening it up to more users and more researchers across the world. And like we said, OCUDU is an open source carrier grade 5G CUDU stack. It's designed for scalability, security, and AI readiness, and it's built on our proven srsRAN project foundation. What is the mission? So open source software as a public-private commons, creating an ecosystem, a community, a platform, a code base under which people can create the next generation of 5G and 6G solutions. We have neutral governance. We have a shared investment across industry, government, and academia, aligning these three pillars of advancement under one community, and then a sustainable community and not a single vendor product. So, we want to bring the srsRAN community over to OCUDU, and then through the Linux Foundation, expand this reach, expand the influence that we have, and expand the opportunities that the community has to both engage with the product and see it used for advanced use cases. So, the timeline up until now, it's been a long journey. It's not just been 10 years of SRS, but there's been a super intensive timeline over the last number of years with srsRAN project. So I guess to give you a little bit more background on this, the srsRAN project wasn't just an evolution of srsLT, right? We completely took the code, we tore it down, scrutinized it, looked at the issues, looked at what was good, and redesigned the GNOB code from the ground up. So there's not a single line of code that is shared between srsLT and srsRAN project. We had the initial release in early 2023 after we started the development at the end of 2021. And then we've had 6 tagged releases between then and now. srsRAN 25.10 was released yesterday, and it's the last official release of srsRAN. So looking forward, over the next 3 years, We'll follow a similar release cycle, so releasing in April and October, and then having 2 releases a year. Okay, so now looking at srsRAN projects, so the foundation. So many of you will be familiar with this. I guess to speak more to the core principles of srsRAN project and why it provides the perfect foundation for OCUDU is because it's been built with these 6 core tenets in mind, right? Like I said, we completely redeveloped the code from the ground up, and we developed it with these principles to ensure that we created a solution that was optimized for not just commercial networks, but for research and for ease of use and user interoperability. So we wanted something that was complete. That means completely developed by us, SRS, not having a reliance on third-party dependencies. We wanted it to be portable, so usable across anything from a Raspberry Pi to a telco-grade server. We wanted it to be performant, so even if you were on these smaller platforms, that it worked. It's no good if, yes, you can put it on a Raspberry Pi, but if it doesn't perform, then it's pointless. So we wanted everything to be performant across all of these platforms. We wanted it to be open, both open source and Open RAN. We wanted it to be flexible, so you could use it for various use cases. And we wanted it to be interoperable, so that you could plug and play with different CUs, different DUs, different RUs, different cores, right? To lessen the kind of reliance on certain vendors. Okay, so that gives you the idea of OCUDU, why srsRAN is the chosen platform on which to build this, and why it is going to enable, this advancement toward 5G and 6G. But how do we engage with the ecosystem? So those of you that have used srsRAN will know that the community is kind of one of the main factors behind why people enjoy using our software so much, right? There's a huge community of developers, not just us, but internationally. Our access to developers in terms of the srsRAN team is very clear, and we have a great discussions board where people are kind of helping people out and can go and get their issues not just solved, but understanding them as well. So we are hoping and will take the same approach with OCUDU. So like we all know, it's hosted under the Linux Foundation for neutral and open governance. There are a few kind of main avenues through which people can get involved. So obviously the technical steering committee, which will guide the roadmap and the release decisions for now, that will be mainly us at SRS. So we're still maintaining control over how the code will be developed and where it will go. There are these special interest groups. So these are focusing on certain topics related to things like AI RAN, testing, cloud deployments, documentation. There's the governing board, which is formed by the member organizations to oversee the strategy and funding. We will have open repositories and tools. So similar to srsRAN, there will be a GitHub repository. And then we will have this community-driven model, right? So where we have individuals contributing, we have universities, research groups, companies, all participating in the one project, driving it forward. Okay, how can you get involved then? So obviously join the community through the Linux Foundation. We will be accepting open contributions. You can collaborate through the special interest groups. You can engage in some of the meetings to help influence the roadmap. You can partner, so LF will partner with universities, labs, and vendors through the OCUDU ecosystem. And obviously, you can stay connected to the community through online portals, but also there will be more events, more workshops, more webinars, and more documentation. Okay, so getting started with OCUDU. So obviously, OCUDU is not readily available to the public just yet, but you can get started through the latest release of srsRAN. So the code can be downloaded through GitHub. I'm sure you're all familiar with this. So here it is for your reference. We have some important resources. So like I've spoken about, we have a very, very large community. All of this is done through and managed through our GitHub discussions. So if you've not used this before, this is a really, really great resource, right? So it's not just the srsRAN development team that are active on this, but it's members of the community, whether that's people in industry or in research groups or universities. And it functions a little bit like a Reddit thread or a Reddit subreddit, where you've got all these threads with certain topics where people are, not just kind of disclosing issues or trying to get assistance with problems that they have, but also sharing some success stories or, giving kind of input on things like documentation that they'd like to see. So it's a really great collaborative space, and it's really helped us to, I guess, not just stay connected to the community, but understand what I'm going to pause and let this guy pass. But understand, what the community are doing and maybe how we can do better and assist them more. We also have extensive documentation, which you can find on our Read the Docs portal. And so this covers everything from installation guides to a dev guide to guides on how we actually write our code, so kind of a style guide on how the code is written and how the code is structured. Extensive tutorials for applications and use cases, and also a knowledge base, so which provides kind of introductory knowledge to ORAN and to 5G and to srsRAN to help get even the kind of newest and most junior users up and running as quickly as possible. All right, so from srsRAN to OCUDU, so taking the next step. So as we've shown, we have a kind of a proven software foundation to ensure the success of OCUDU. We will have a neutral and open governance, and we'll have a shared ecosystem across sectors. So we're going to bring all of these together to hopefully build the Linux of RAN, or not hopefully, but definitely will build the Linux of RAN. All right, so that's it. I hope you learned something new. I hope that helped to summarize some of the points that were raised yesterday. For now, I'll open the floor to questions, and if not, then thank you very much. No questions? Oh, sure. No, go ahead.
I think everyone's thinking the same thing.
Yeah.
Trying to think about wording it the best way. But it seems like OCUDU, I guess you'll send it out to the public. If anybody has the hardware, they can try to implement their own CPU framework. I guess one concern, I'm trying to word this carefully.
Yep.
Okay. So the US has various different needs and various technologies that have been deployed by large service providers. One that quickly comes to mind for me is FR2, whereas most of the world, except for I think like China, maybe even like I don't think even South Korea or whatever. I'm not sure. This might be like 2 years old knowledge, but they mostly still mid-band. Would this be applicable? I guess somebody would have to build all the code from scratch, I guess. To be able to deploy, let's say, something like FR2, which I think has a lot of different components to it, lack of a better term, like numerology.
Mm-hmm.
There's a lot of technical aspects that would, that would be a large buildup, I guess. Or will some of that kind of come in with the original package?
So are you, let me try to understand the question so I get it right. No. So are you asking, if FR2 will be available within OCUDU? Yeah.
I don't know if that makes sense to ask.
No. So you're kind of asking, I guess, about the kind of the features and the roadmap, right, on what we'll have. So
Yes.
FR2, to the best of my knowledge, will be one of the features that launch with OCUDU. Andres here, correct? Yep. So,
Nice.
I mean, if you've downloaded and run srsRAN, it will work the same way, right? So you just clone the repository and build it. And from there, you have all of the features that are listed in the feature set. So it's very simple. You clone the repository, you build it. It's kind of a 3-4 commands. And then once it's built, you have access to all of the features, right? So you just launch the code with whatever compatible, as long as you have an FR2 compatible front end, then you will be able to stand up an FR2 capable network, if we want to call it that, within, depending on the computer you have, if it's quick enough, a matter of minutes, right?
I guess also the question to understand how OCUDU would work, right? So a person who wishes that would exist would download the code, make that happen.
Exactly.
And then they can freely upload their code back.
Yes. So if you were to, I don't know, we'll say you're doing some research on FR2 and you, I don't know, let's pick something. You modify the scheduler, right? Or you do a custom modification to the scheduler that is something in the standard, right, that we don't have yet. Those, and again, to the best of my knowledge, such additions or modifications can be, they'll have to be submitted.
Like any normal open source project, I mean, you create a pull request. You adhere to the development guidelines in terms of quality, documentation, testing of all those features that your application has did. And as long as that is passed, I mean, you're happy to accept those.
I guess you guys would have a pipeline of
Yeah. So there'll be a CI/CD pipeline.
Part of the main OCUDU repository. Like yeah.
Thank you.
I just to so that the camera audio picks this up. So yeah, any user that is modifying the code and wishes to contribute those modifications back upstream to OCUDU, you just create a pull request. It'll be reviewed by the technical steering committee. Then it'll go through a series of tests to make sure that it conforms to the development standards and the tests that we have. And then if it's successful, it will be merged into the code and then published. So yeah, we will be accepting open contributions to OCUDU, and it will work in the same as any other open source project does. Answer the question? Yep, great. Sure.
This is the thread number 423. Thread number 423.
2, 3.
Architecture.
Yes.
So
Yep.
we are thinking that the software will be used over the Kubernetes environment, K8 environment. Then in that case, we think that there are two possibilities. So one possibility would be that each component, like RLC Mac, would be deployed over pod. And then another deployment would be each component, like RLC Mac, be developed over Docker. And then all DU would be deployed over one pod. So in the current code base, which is supported? That's my question.
So the question is whether or not you can run Kubernetes pods or Docker. Is that correct? Yeah, so we have instances where both are being run. So we have scripts. Sorry. So for those of you that don't know, let me introduce Andre Pushman. He's our VP of Engineering. So it's great that he's attending this talk to take some of these questions.
Yeah, so the question was whether we can run those as individual components that is shown here now as one picture. And at the current, let's say, component level that we are having is like the DU, the CUUP, and the CUCP. And among those components, we have those interfaces that we see, and we are exposing them, and you can run them in individual pods. And in the code is, yeah. So in different individual containers. Or you can combine them all, which is kind of the co-located use case. So if you're running them on a single node, you can also combine them into the G-node view, which is kind of the entire application. And then they're just running inside a single application, running inside a single pod. What we don't do is, because there's also no standardized interface between RC and Mac, so within the within the DU high, so this, so between RC and Mac, there's no standardized interface. So it would be not natural to run those components in different pod scale, because we need to define something so that it can communicate. But DO we have over Fabi we also have internally. So if you were to run Kubernetes or in the Kubernetes case on an embedded platform that maybe is providing Hi-Fi in for instance FlexRAN or Aerial, so you can also do that and only have the DU application running the DU high that you see here, Mac and RC in one pod talking to an Aerial file or to a FlexRAN file, so you don't do that. But this is exactly what we are providing, and I don't think there are any codes to further split it apart because of this interface issue that I mentioned earlier.
So you mean current implementation would be one pod?
The DU? Yeah.
DU box will be one, and then inside the pods, like Docker or Mac and everything.
No, it's one application, one binary, and that runs inside one pod. That is the DU pod. So whether that's DU high and the DU low combined, or just DU high, that is up to you depending on where you want to implement the file. And then the other one is then the CUUP and CUCP that you see on top there. And you can run them in different pods as well. Using standard F1 or U1. Yes.
So I guess to just explain this to the room a little bit so that everybody can follow along with the conversation. So within the srsRAN project code, once it's built, you have a couple of options. So you can build a full application, which is like the monolithic G-node B, so everything in this kind of darker blue here. There is also the option to deploy just the DU as an application. just the CU as an application and also split the CU, UP, and CP. So you have an option of 4 deployments. And this means that you can then integrate each of those aspects with third-party components if you wish, or if for some reason you want to run, for instance, the CU in one location and the DU in another location, you can do that as well. So this means then we can run it on things like Kubernetes and Docker. Does that answer your question? Yeah? Cool. Yeah, perfect. I think there's a lot to unpack there. Any other questions from the room? Yep, sure, go ahead.
More kind of generic question. So I see that you have these kind of like cadence releases.
Yep.
Is there any reason why kind of keeping that? I mean, because I guess you're not releasing features every 6 months, right? So it's a continuous process. What is the benefit of having these 6 months releases?
Yeah, so there will be. Let me go with this, and then if Andre needs to clarify, we will. So how we currently run it is that we have kind of small releases quite regularly. So there's kind of a 2-week cadence. So there will be kind of small features released every now and again, and then these larger releases. Let's just go back to srsRAN because that's what we're talking about right now. These larger tagged releases are just kind of more, let's say, like developmental milestones, so that in these large tagged releases, they are like stable, complete versions of all of these features.
And if I want to use one specific, let's say, feature that you have every 2 months, is there any official tag for that?
Yeah. So if you wanted to just, we'll say for instance, you had checked out 24.4, right? And you had that working in your setup. And then you update to the latest release and something breaks because, I don't know, we've changed how something works in the scheduler. You can just roll back to the previous release because they're tagged. So they're kind of stable milestones, not just for us as developers, but for users as well. You have instances where people prefer to use 24.10 because that works in their setup instead of 25.10.
No, that's
yeah.
But what I'm saying, you say that you typically kind of release every 2 weeks, kind of like minor features. Is there an official tag for those minor features, or how?
No. So they're kind of running freely between. I mean, you can check out like the specific commit. So if you knew that like on Tuesday the 11th of April, that's the yeah.
Okay, thanks.
Yeah, maybe just to clarify on why this is why we are still doing that with OCUDU. And then of course you're right. So in theory we have rolling release because everything is updated in the public, and we don't do that bi-weekly pushes. But for OCUDU, the main reason here is that being in like the OCUDU project, running over the course of 3 years with attached milestones to it. So we kind of have those releases and attach those to those milestones and the features attached to those releases. And then we are going to have external partners testing specific features that we said we are going to deliver in that time frame using those tech releases, more or less. And that's why we're having that strict roadmap saying that in October or in April we're delivering those specific features, and then external partners can come and evaluate them using the tech release. But obviously, this is not something. Like the idea here is also the vision behind that is also to not only have a new stable release every 6 months, but have that continuously. Yeah, exactly. And the release, like the linear history issue that we discussed earlier as well, that is something that will also change because of the development taking place in full public, and not us kind of doing it internally and then basically merging or putting in our internal development into publics. So it's improving. So that going back will work.
Cool. All right, thanks.
Yeah, and I guess one thing I actually would like to clarify based off what Andre has said there. So currently how srsRAN is developed will be different to how OCUDU is developed. So right now we develop srsRAN on an internal GitLab repository, and then that gets pushed to the the public GitHub when certain milestones have been reached or certain features have been developed and the tests have passed and gone through a stable. With OCUDU, everything is going to be open. So like the guys said yesterday, you'll be able to see our conversations on merge requests. You'll be able to see our conversations on issues. So you'll get a much more open view of the inner workings of SRS and how we're building the code. The benefit to that is that users will be able to understand kind of why we made certain decisions and why certain features have been developed certain ways or why the code has been written in a certain way, which will then hopefully make it easier for other people to contribute because they'll see how we're working, and that will help to influence kind of the development work that they're doing. So I hope that's a better overview of that. So do we have any other questions? We have a little bit of time, and I'm happy to keep this as kind of an open discussion. So if you do have any question or something you want to ask, just yeah, shout out. There's no problem. No, everybody's happy. Okay. I think for the first time we're running ahead of schedule. Oh, sorry. Go on. Go. You got loads of time.
Requests or merge requests depending on what kind of using GitHub.
Yeah.
So the CI/CD pipeline is something that's going to be kind of like open for users to see, or you are planning to have something like a on-premise pipeline or infrastructure for that?
So the question is whether or not the CI/CD will be open to the public, and for that, I'm going to ask Andre. He's got all the answers.
Yes, of course it will be public, and so we are going to set the way we currently think about that is to establish kind of a two-layered approach, where the first layer is using only like cloud resource without hardware dependency. So we're not going to test any feature end-to-end with real radio hardware. Something that we are currently doing in our srsRAN development process. So that we need to abandon because it just simply doesn't scale well, and we cannot have potentially 100 committers opening pull requests and then exercising our internal lab infrastructure. So that's not going to be the case. So we will entirely rely on self-contained unit integration testing that runs in the cloud. Just a normal pipeline, right? Doing builds for operating systems, for certain compilers, something that can be run in the cloud. And then there will be, and that scales up, and then if the pipelines run too long, we just get more resources and run them in different, on more servers, right? And then there's the second layer, which we currently are thinking will be essentially extending that pipeline by adding end-to-end testing, stuff that we are currently doing for srsRAN in-house in our on-premise RF setup and in the lab. And that is something where we are also, so we have internal testing tools and test orchestration and test automation systems where we are not only exercising the GNOB, deploying that in Kubernetes, running end-to-end tests with core networks and even orchestrating a commercial test measurement equipment. All of that will also be open source. It will be a different repository with extra pipelines. And we will provide a reference implementation of that, running end-to-end tests with nightly releases of OCUDU that are exercised in that second layer. But at the same time, we welcome everybody to kind of fork that and do their own implementation of that, running on-premise, using their equipment, and kind of trying to replicate that across the board. So you can do that internally with whatever tools you're having or equipment you're having. OTICs could do that. Universities can do that depending on the resource that they have at hand, and essentially expand on that. And the idea is also to be able to have a way to communicate the results of those pipelines back to the project and collectively a set of going back to that question regarding text, basically crowdsourcing the CI results for specific OCUDU releases is something that we are thinking of doing. Let's say 2610, we obviously tag that release, we run that through our internal layer, second layer CI, but also several OTICs to that, and then report back that result, listing that, and over time we see that this report or this specific release has actually been not only verified internally by SRS, but also by other third-party labs around the globe, and kind of adding extra confidence to that. So that is a little bit the thinking that we have behind that. Because RAN testing is complex, and you cannot really avoid the end-to-end thing, as you know. But at the same time, we need to balance the trade-off with the hopefully increasing user community and
are you expecting to kind of like take advantage of the the srsRAN, kind of like complete an end-to-end pipeline or somehow help you on this validation?
Yes, so srsRAN, we are also using that internally in our test pipeline. The issue here is that it has limited functionality. It's not on par with the features, and especially looking at the roadmap, that gap only, as we speak now, that gap only becomes bigger. So we actually rely on third-party UE emulators or third-party test equipment to close the loop to do end-to-end testing, or COTS software or COTS handsets, but this also doesn't scale. So that is a little bit the problem here.
So basically, is no plans to kind of do any improvements on the srsRAN, kind of catch up to the whole end-to-end?
Yeah, I mean that's currently the current state is that that's not the case.
Cool, thanks.
Okay, unfortunately we don't have time for other questions. We have to move on to our next presentation. So thank you all very much for your attention. I hope that you learned something, and thanks to Andre for fielding some of those questions as well.